Welcome all you tech enthusiasts, you curious minds, and those navigating the electrifying world of bits and bytes. This is 𝐸𝐻𝐸, the podcast that promises to be your guide through this ever-evolving universe of IT and beyond. So, let's do it! Hi everyone, this is 𝐸𝐻𝐸 in an online version. Welcome everyone. Today we are talking about robotics space and robotics in SoftServe. And to help me do this, I'm not a robotics guy. I have some experts, I have some leaders with me to help debunk this topic. So I have Lubomir and I have Yuri. Hi guys, how are you?
Hi.
Hi.
Nice to be here.
Good, glad you found time to talk to me. I really hope that you will help me understand this better and help the audience understand this better. We will talk about some technicalities behind robotics, but at the same time, we'll talk about kind of business side of robotics and how that kind of applies in our business world and industry. But before we do that, very brief introductions, guys. Lubomir, let's start with you. Can you tell us and the audience just a bit about yourself?
Yeah, sure. So I'm my name is Lubomir. I'm director of robotics and advanced automation group here at SoftServe. And yeah, as a group, we are dealing with various types of robots, including software side and hardware side. And yeah, so we are delivering the project on Earth and in space.
Nice. Okay, perfect. I should really call you sir, I think. How long you've been with SoftServe for?
I'm with SoftServe for 7 years already, so it's like pretty nice journey. Before that, I was with academia for some time and also doing some IT, IoT, and robotics related projects. So yeah, so that was
okay. Okay, perfect. Thank you, Lubomir. Yuri, let's come with you then. Tell me, who are you?
I'm fine, yes, thank you. And yes, my name is Yuriy Fedyuk, and I'm working with SoftServe already 7 years as well, and particularly with robotics team 5 years, where we started, well, it was a group of 5, I guess, when I joined the group. And now I am in position robotics cluster lead, where I'm focusing on robotics integration and operation. And over this time, I helped several clients with robotics solution. Actually, we are working on one of the biggest solution for our client, where we are developing robots from scratch to improve their businesses. And yeah, and I'm really excited to be here.
Thank you. Impressive. When you talk about this, developing robots from scratch, I think about all those MIT developed robots that we see on the internet. It's the first thing that comes to my mind. Good. And quickly, because you guys are on the same location, where are you based?
Lviv,
right now?
Ukraine.
Lviv. Perfect.
Actually, based in Lviv as well, but living nearby Lviv, more close to the Poland border. Yeah.
Nice. Okay, good. All right, so let's maybe get into this merit of the conversation about robotics, and maybe we'll start from the very kind of top and the basics, and what exactly do we mean by robotics, and let's focus on that kind of business context today. Lubomir.
Yeah, so it's a good question, and if we will go to the definitions, we call a robot everything that moves in 2D. So if this is an object that is able to move itself, then it's already a robot, and usually that's the minimal requirement. And if you think about the robots, they are there in the industry since 1956. Robotics arm are already helping in the factories doing some actions. So they are basically we're trained to move something from point A to point B, hoping that the object is there. And now when we are thinking about the robots, now we are thinking about something that is more smart, with more sensors, more capabilities, more autonomy, actually. And yeah, so that's the natural evolution of the field, I guess.
Okay, 1950s. That takes us a while back. Is it any particular industry back then when it was implemented? Was it automotive? Because this is the kind of first thing that comes to my mind is automotive. But Do you know by any chance which industry was it that implemented robotics back in 1950s?
I cannot tell you which one was the first, but it was manufacturing. Robots were working at the conveyors, had to help in handling the items. Maybe you know which one was the first.
Not recalling that, but yeah, the industry started with robotics arm, with simple task pick and place into different areas with predefined motion, and now we can talk about that robots are everywhere. Even I think each at home we have a vacuum cleaner that's also part of the robots, as they are able to navigate inside the environment. Also, all warehouses, modern warehouses, are full of robotics, and even agriculture now. It is impossible to work in current time without robotics in agriculture. Like it's with some heavy machines that communicate with each other, or drones that monitoring fields.
Yeah, it seems that we see robots everywhere we go these days. Obviously, depending on how autonomous, how smart they are. But we'll get to that topic. But thank you, guys. But now, kind of continuing this topic, it's curious to maybe understand what's the ultimate goal of robotics in the business world. Is it efficiency? Is it something else? Is it cost reduction? What do you think, guys?
From my understanding, like it should be cost reduction plus efficiency, because robots can operate more reliable, and it can perform repetitive tasks one by one. That is, for the human, it's very hard to do. And with robotics, pick and place operation, and it can be done each day with the same precision. And also we have like shortage of people to work in the world. So we need to think about how to not only reduce the cost, but also be efficient, and how to use people that can do like high level tasks, and robots that can do these repetitive tasks. So.
Yeah, I meant to actually follow up with human augmentation. It seems the case, but also what it creates is you will need people that would maintain those robots and calibrate those robots, right? So that this is not like it's just a complete human augmentation.
Definitely on current stage.
Yeah, well, yeah, robots maintaining robots. I've seen some of those. Absolutely. Lubomir, anything to add to this?
Yeah, I think that the robots, it is said that they work in 3D, so they are working with tasks that are dull, dirty, and dangerous. So these are the primary tasks for robotics, and yeah, and again, they are evolving. And when you are talking about human augmentation, I'm thinking about robots working alongside humans, and that's really something that where we are heading to. When we are talking about the robot, there's I had an interesting conversation the other day, and the topic, what is a robot, and the question is, aren't we robots also? So let's think about that robot needs some energy to operate. Do we need energy? Yes, we are eating. That's the reason why. Robot can be programmed. Can we be programmed? Think about elections. We are so it's we robot need maintenance. We also need maintenance. We have hospitals, so it's it's
that. Do you know what? You just start a whole completely new direction of this conversation. Very ethical, very philosophical. But I like it. I like this analogy. Yeah.
Yeah, it can be a topic of another conversation, because it's really had us a bit far from business, but you always have to keep the bigger picture in mind when you're talking about all that stuff.
Absolutely, thank you.
So for now, like human robots maintain like hardware robots.
Pretty much. That's how I hear it now. Perfect, good. And actually, just focusing on this is a question and answer focused on industries themselves. Let's talk about the few examples, maybe if you have any, where robotics made the most impact on particular industry and delivered significant business value. Are there any in particular that you can think of?
Well, I guess if you're talking about robotics, then manufacturing is the biggest industry for robots.
Mm-hmm.
And for various types of robots, robot arms that help with the conveyor, AMRs, AGVs, so mobile platforms that are navigating around, helping to handle the different items that are there. And it can be a robotic system, so it can be like a mobile platform and a robotic arm that help to load and unload shelves. It can be autonomous forklifts,
Mm-hmm.
robots for inspection, etc. So this is
Yeah.
the industry.
I think I've seen even a few videos from, I think it was Amazon warehouses where there were autonomous forklift drivers, forklifts, right, moving pallets around the warehouse.
Yeah, retail is indeed the another industry that is there, and yeah, so that's the thing, because as Yuri said,
Mm-hmm.
we are like longing the sufficient amount of skilled people, and forklift drivers are also required there. So autonomous forklifts is something that is almost here.
Yeah. Yeah, perfect. And do we have any potential cases from SoftServe that we worked on where we applied any robotics principles? Anything you can disclose, by the way, obviously, without any giving away secrets.
That's a good note, because we are having NDAs with our clients that we cannot break. But yeah, so we have a recent project with Toyota Material Handling that where we help automate the forklifts that are working in the environment. So that's one thing. We are having the so that's as a terrestrial case, right? But we also when we're thinking about space, the robots are ahead of humans, because on Earth humans are ahead of robots, and in the space it's vice versa, because of the conditions and lack of oxygen. And we are collaborating with NASA to enable the autonomous robotics fleet for creating of the launch and landing pad on the moon to increase safety of those missions. So these are like
Impressive. Wow. Okay, NASA. Yuri, anything you have in mind?
Yes, I would add several use cases that we are working with agriculture, where we are helping our customers to get better yield on their fields, on their environments, using the same amount of energy, the same amount of pesticide we need. We like improving their yield, and we are helping with such things to collect even data that can be then used to, for analytics to again to use for better, to have better yield at the end.
Perfect. No, that's a perfect example, especially in the current world economy, to help automate. I'm assuming it might lead to driving the cost down a bit in the future.
exactly.
Fantastic. And a very quick question, actually, because it kind of came to my mind about the business side of it, and how do we, build a business case for investing in robotics and automation? Because not every, industry, not every business wants to invest in those machines or robotics, and it's curious to understand how to convince, for example, the board of directors or whoever from the business side to actually invest in this space. Are there any principles like return of investment or any other principles that matter in robotics space?
Yeah, so obviously when we are talking about the business case of this robotics innovations, we have to talk about return of investment and on investment itself, as well on about technology reliability. So obviously when we are having like traditional manufacturing process and lots of humans are involved, it takes some things like compensations for humans, also some social packages, etc. There are also some injuries that are that are happening in the manufacturing, also human errors that happened, and also this affects the manufacturing process. And also humans work in shifts, so more than 8 hours. It's like not I hope it doesn't happen anywhere. So and in contrast, robots do not have those issues. They can work 24/7. The accuracy is constant, but they have some cons from their side also, like investment price. You have to indeed invest into robotics. And when we are working with robots, we are thinking about flexible robots that can adapt to the environment. That's really important for us, to have minimal changes introduced into the environment where those robots operate. But also the maintenance cost, as any hardware, they can break. And so there's some downtime can be there. So this is all calculated, and obviously we calculate return on investment, but also the increase in revenue, because when we are talking, let's say the agriculture case, we can increase yield, as Yuri said, and this is not only about substitution but about improvement of the business outcomes. So that's I guess it.
Yeah, and adding
I
speed and
would add
efficiency.
to this also, for example, there are industries where like person need to be very, very educated over the time. A person should get this experience from the processes, or for example, on the factory. And like it's very hard to spread this experience over the world. And with robotics, like you teach one robot, he operates good, and then one update, and all factories around the world are operating with the better efficiency. And yeah, you can you get better yield. You have like you spend less cost for the maintaining this.
Yeah, and it's a nice example, by the way, that Yuri just mentioned. So we had a client who had a factory where machines were from different decades, so some were older, some were newer, and some machines were operated by operators who, there were some switches and knobs that had to be rotated, and the decision by humans were made based on the smell of the machine, sound of the machine, vibration of the machine. And when a newcomer comes, it's not so easy to teach how to smell the machine properly in order to turn the proper knobs. And if you introduce some more sensors, and if you introduce robotics that can substitute all those processes, it makes it easier because you don't have to train. And additionally, if you're talking about some big clients that have multiple factories, the knowledge sharing process gets much easier with robots, because some especially if you're talking about some seasonal businesses, then the same problem might occur in different facilities in different years. Let's say there was a problem, and then in another facility in another country, let's say it happens in 5 years, and during those 5 years the knowledge can be lost, or it can be transferred incorrectly, or people can just leave the business and go somewhere else, and the knowledge is then totally lost. And this is not an issue when we are talking about robots, because it's all there.
Yeah, and one more maybe from my side, because kind of from listening to both of you, it seems that with robots, obviously we get consistency, right? This is the kind of main aspect of having robots, especially when you have multiple factories, you have robots performing the same job, and that outcome is consistent because it's hard-coded into the operations of that robot. With humans, obviously, you have fluctuations of consistency, as you said previously, with some human errors and injuries, etc., right?
Yeah.
Absolutely. Makes sense. Seems like it's not that difficult to sell the idea of robots to a business using business case. Okay, answer me this question without maybe, again, disclosing anything, but are robots expensive to implement? Or is it moderate amount?
What do you want a robot to do then?
Yeah, let's focus, because we talked about logistics.
For logistics. again, logistics. It's to take something from Earth to Moon. It's also logistics, and that's really difficult. If we are talking about having, let's say, as Amazon does it, in their facility, a robot that lifts the shelf and drive it to the other location, that's much more simple. But if you are thinking about this Amazon case, you don't have to think about one robot and that's it. It's always a robot fleet. So now you have multiple robots that have to mind the locations of each other, that has to have the optimal path for to navigate through the environment. The scheduler should be there because if you are doing some packaging for the customers to be received, you don't want to have one robot wait in a line when his turn comes just to the corresponding item to be grasped from the shelf, but you want to optimize based on the order. Then you have to have connectivity to the cloud, to store, so ERM, WMS. So it's a complex project that has multiple layers. And when you think of that, the question becomes, yes, that is some effort. So if it is one robot that has to do a pick and place and that's it can be pretty simple. But when you are talking about production project, it suddenly becomes much more complex.
Yeah.
I will add here that it will be easy to implement, but cost of this single robot will be huge, because when we are creating a robot like from idea, from scratch, when all hardware parts are custom made or like purchased, usually we have this 3 iteration of hardware. That first prototype, then we are redesigning around 50% of the robot, and then we are making adjusting during the 3rd round. And with hardware, like it's impossible, like it takes time because it should be designed, it should be manufactured, it should be designed. And usually this round takes from 1 month, I guess, to till half of the year, depending on how many components we are manufacturing and designing, and when we are receiving. Because, for example, we can wait for some hardware parts for even a year if they are not available on the market right now. And it also adds this cost to the robot.
Yeah, I mean, thank you guys. And this is actually why I asked this kind of maybe curveball question, because it seems like a significant investment from the business side. But again, there is a cherry on top. At the end of the day, there is a return on investment that's significant even more, right? So that's why I wanted to kind of ask this question. And it leads to maybe a next question I have for you, which is, where do you think we are on a maturity curve of robotics adoption in business? It seems from some of the examples you gave me that we're quite advanced in maybe late stage, but maybe this is not applicable for all businesses, all the industries. What do you think?
Definitely. For example, if you take into account manufacturing, it is mature, I guess, because I suppose 80% of the work in manufacturing, for example, car manufacturing, electronics manufacturing, is done by the robots already. And humans here is for even inspection is done by the robots with computer vision and like AI tools now. And when we go to another areas like agriculture or healthcare, I think also healthcare is growing right now with these surgical robots that can be teleoperated. And then with agriculture, more and more robots are going to the field, or we have some controlled environment to grow plants. And it's really, really like we have huge growth right now across different areas. And I think all areas are touched by robotics right now. But not all are mature enough to use.
It seems that way, yes. Thank you, Yuri.
I would add to this that you are saying, is robotics mature? And this is like not the very correct question, because you should not think about robotics as of one thing. Because obviously we have robots since 1950s and they are working well, they are introduced. So since they are for more than 60 years here, so obviously the maturity is there because it took us a while. But the robotics is a field that is constantly evolving, and we have to think about like mobile platforms. Okay, robotics arm that are just doing pick and place from the predefined position. They are doing awesome stuff. But if you think about, let's say, elect robots, humanoids, robots, this is not there, and it takes robotics to yet another level because it increases flexibility. Because if you have a production line that consists of, I know, 20 to 30 cells, and you have to have at least one robot at each cell, well, that's cost not so much efficient, let's say. But if you can have one robot or two robots that are working along those cells, doing the stuff at each cell, and they are flexible enough to do that, well, that's something else. So it's different curves of robotics technology, and one is changing the other. But what's important for me that like when we started in 7 years, robotics was, hey, that's fun, it's for conferences, just to show that we can do this. In 7 years from now, nobody thinks like that of robotics. Everybody in all industries understand that robotic will be there. Yes, sooner or later, but there is no doubt.
Yeah. Thank you, Lubomir. And actually, you made an excellent point. Actually, outlining the robotics is not as simple as maybe some people perceive it to be. Right? It's not just a Roomba vacuum cleaner running around your house. There is so much more complexity behind it. There's different fields within robotics, right? So it's not just simple. So maturity level obviously varies depending on industry and field of robotics and its application. Good. But you guys mentioned one thing which I want to move on to, and I love this topic because it's very current, which is AI. Yuri, I believe you mentioned some AI there. And my next question is actually, what is the relationship between robotics and AI these days, or is there any?
Well, I believe they are tightly coupled because this is what makes robot smart. And when we think about robots, we can think about in terms of software, right? So we can, because AI is mostly from the software side. So we are thinking about several layers like control layer, and the algorithm like PAD is de facto standard, but now we're talking about MPC, fuzzy, and other algorithm, and the portion of AI there increases. So we have some neural networks that model the system that is being controlled by them. So this one grows. Then we have algorithms like for navigation and manipulation, where the portion of AI is there, and it is doing the things, and also the decision making, like perception, etc. So that's something that allowed robots to be smarter. But now, from the technology standpoint, we are even further because we are now talking about foundational models, and this is something that combines LLMs and computer vision, and it helps to have not to have these layers that I mentioned, but rather to be able to augment all these layers, so the robot are controlled by one, maybe not one, but the set, let's say, of physical AI agents. Now we are not talking about robotics itself; we are talking about physical AI. So it's basically robotics, but yeah, exactly. So this allows to be able to like optimize operations and make them more efficient. There is one more thing that we do not have to forget. The robot has to have stability, and all that fancy, let's say, and useful AI stuff. Maybe I missed that, but I haven't seen the mathematical proof that they are stable, which means that some disturbances in the system input will be followed by limited disturbances in system output, right? So therefore, the classical control theory that is mathematically proved to be stable that is controlling the motor should be always there.
Yeah, good. I mean, that's good news, actually. I mean, obviously, we want them to be perfect at some point in the future, but we need to be ready for it, right? But good, because what you mentioned previously is actually very interesting, Yuri. I'll give you a mic in a second. But what it seemed that, when we talk about AI, again, some people might think that, automation is AI or augmentation is AI or some other kind of workflow generation is AI. But AI being the technology that allows you to interpret environment, to make decisions based on different factors, that's feeding the machine, the robot, right? But you said it right. We're getting there, but maybe not 100% ideal yet, which is, I think, maybe good for now. Yuri.
Yeah, and what you said, it's like AI is a brain and robotic is a body.
Mm-hmm.
AI thinks what to do, like interpret a word and make a task for the robot, and then robot executes. Because without AI, robots can do only repetitive tasks.
Mm-hmm.
Pick and place, like I'm going to that position using some planning scene and pick, place, without AI. And to be honest, we don't need AI to do it.
Yeah.
It perfectly works without AI. But when we are talking that, okay, now this robot should not only pick up, but also identify if there are something to pick up or where it is located, then we are going, okay, now we need to AI to identify the position. This is like very first level, like identify position to go and pick up this object. Then what to do with this object, how to pick up this object, where to put this object, because maybe you need to sort some, I don't know, balls into different buckets. And you don't need to like program, okay, now identify that this bucket is yellow, or this ball is yellow. You just say for with current technology, it is not how it works, but you can say, okay, yellow balls to the left, red balls to the right. And it works. Not every time, but still it works.
Yeah, the one analogy I always make is if I have a humanoid robot in my home and I want it to make me coffee, it needs to know or find this coffee on a shelf somewhere or in a cupboard. It needs to go and pick it up and use a spoon to put enough kind of coffee into a cup, etc. There's so many different tasks, but it needs to interpret the location around it to determine where the cups are, where the coffee is, and so on and so forth, and how strong the coffee needs to be, etc. Right? So, and maybe one thing I'm going to add, because I think I said it on the previous episode I recorded about robotics with your colleagues. I'm a huge fan of movie I, Robot, right, with Will Smith, and this is what I imagine, what I see in my mind when we are talking about robotics, those humanoid, good or not so good versions of robots, right? With those three laws. Good. Moving on, guys, because Lubomir, you actually said another interesting thing about reliability. I want to maybe follow up on this, about how do we balance this innovation, this rapid innovation and growth in robotics space with reliability and safety when developing those systems?
Well, when we're thinking about any robot, we have to keep in mind always that this is a like piece of metal that can harm humans. So safety measures are super important. I mean, it is a fun story. So we were in the desert for 𝐀𝐻𝐸𝐿 challenge, something like 5 years ago, and there were a team of robotics developers, engineers, and also then came people who were shooting us, like with drone to create a movie, like a commercial about the team, and they had a drone that they flew up on top of our heads to shoot us from the sky. And everyone who was robotics engineer, they did like this. They covered their heads because they knew that if this drone falls, there might be serious injuries.
Damage.
And the rest, they were saying, "Hey, drone, hi, it's great." So you see that if you are all robotics engineers have this safety built in because they understand that it's super important to keep this in mind. So yeah, so and it's you mentioned innovation, so there are different phases when you're talking about the robot. So one is when you are doing indeed something new, you innovate, and the robot is in your laboratory, then you have to prove that the technology works and that it is possible to perform. But when you are doing this, you know that there will be no other humans around. As soon as you're moving it to production, you have to ensure that the robot will not harm human itself and the environment. So there'll be multiple ways of that. Let's say in EU there are some sensors that are certified for the robots that are working alongside humans. We also have, when we are talking about robotics arm, we have cobots, so collaborative robots that are again built for the case that they are working alongside humans, and if they will harm you, they will stop because they have torque sensors that will tell you that there is some unknown obstacle, human or something from the environment that is not supposed to be there, and the robot should stop. So that's built in.
Yeah, thank you. Sorry, I just kind of sprang to my mind. I've seen this video of this milling saw, like a carpentry saw that kind of cuts wood, right? And then when it feels and senses moisture, like human finger, it just hides automatically very quickly because it's a safety feature, right? So this is the kind of thing I'm considering. Good. I'm assuming that in this case, safety tests are one of the first that are done on the concept level, right? To make sure that whatever is being created as a robot, it's safe to coexist.
I'd rather not say that this is first, because safety is something that holds the innovation mind. So again, first we are working in the laboratory and we want to prove that something works, and then just everyone knows that, hey, don't come close because it can just kill you or injure you. So please, when the robot is on, don't be there. And there is each robot has a big red button, and there is a person that should be standing nearby. If something happens, this red button should be pressed and the robot just stops. So this is the feature that is always there. But again, once we prove that technology work, when we prove that we can do what the robot is supposed to do, then we are adding these safety layers. And when we are thinking about the architecture, like right, so it's like a set of diagrams. So yes, there is a safety block there, but when we are doing just the initial steps of the development, it's just a plug, a big red button, right? But then it is being enabled because we want those robots to be safe.
Okay, perfect. That's good. I like the concept of the big red button. Thanks. Yuri, anything to add here?
And I guess it's improving. You mentioned about the drones that was in the sky, and everybody makes such thing. But will you do this today? The same when the drone just taking some photos?
I'm from Ukraine, and each time I hear drone in the sky, I go somewhere in the basement.
Yeah, circumstances related, yes.
Yes. But if it is just a simple drone to take photo. So I think safety now, we know that these drones are working very good, and the probability that it will fall down from the sky is very, very low, because there are different algorithms that allow even to make automatic landing when something is going wrong without human interaction. But I agree here that each robot should start with a big red button and make sure that it works. Because in my experience, we had situation when we pressed the big red button and it didn't work. And it was a surprise. Hopefully nobody was harmed, on the environment, but it was repaired in few minutes. And we should rely on the safety. But for example, it's very hard to make safety with humanoids robots because, again, a lot of AI inside. And when humanoids, like we still do not see humanoids robots that are walking around because of this. But they are starting to work on some closed environment on the manufacturing process. And we expect that it is safe for now, that, okay, robot is doing his job in the closed area, no humans inside, everybody is safe. but still, I think we have a remote red button to disable it, because it will be very dangerous to go to the humanoid robots. That is crazy to disable it.
I was just about to ask if I knew there is a remote button, but is there actually a physical maybe button somewhere on the forehead or a back of the humanoid? Just when it catches you, you just press it to shut down. That maybe there should be.
Yeah. And I just want to add to the safety that if you're talking about human safety, it is two-way road. So it's not obviously robots are to be safe, but also humans should behave safely. Like we have extended reality team and SoftServe, and one of the services that they are providing is like because first of all, we are following the simulation first approach at SoftServe, which means that we start each project in simulations, tools like NVIDIA 𝐀𝐻𝐸, algorithms, 𝐁𝐨𝐝𝐵, etc. Because if you are a software developer and you are just finished writing the last line of code and you are pressing run for the first time, 99% something will fail. You just forgot something. And when you are thinking about the robot, if you are doing development on the hardware from the first time, which means that your costly hardware, $20,000, $40,000 more, can break against the wall, and you don't want this to happen. So you are using simulators. So this is a software that takes into account visualization, physics, interaction, collisions, etc., where you test the algorithm first, and when it works there, we are doing hardware adoption on their hardware robot. And so I started with the XR team. So XR team has a software that can integrate with this simulation. Human puts the software, this headset on his or her head, and there is a training how to work alongside robot. So this also increases safety because humans know what to expect from the robot. And on the same side, when robots are being developed, it's important for the robots to act predictively. So if you are having a robotic arm, it should act not unexpectedly for the humans. The motion should be something similar. Otherwise, humans are just scared naturally. And so that's how the technology is developing.
Good measure, absolutely. And I was kind of smiling because this is what we discussed on the previous episode with Jakub and Mariusz on robotics topic, and specifically on simulations and prototyping, right? A huge and very important stage in robotics development.
Yep. But we are talking about business, and this simulation first it's important for business also because it allows to reduce the cost of the project development by approximately 30%. So you are not harming hardware from the first side. Therefore you are saving money. You are developing in simulation. So imagine that you are coordinating the robot and something went wrong. So we have to stand up from your chair, go there, renew everything to the initial position. It takes time. In simulation, you're just pressing a button and everything is in their place.
Resets.
So we calculated based on the numerous projects that we save 30% increase in quality. And additionally, we can have some unexpected situations, so edge cases in simulation. Let's say you are developing a software for autonomous vehicles and there is a deer crossing the road. And obviously, you don't want to have any accidents with the deer in the real life. And secondly, it would be difficult to ask the deer to cross the road with some speed and at the predefined time. And in simulation, you can have all there, so you can increase the data set for your models. So this increase quality. So it's not about technology only, but how the technology and approach can help business save money and speed up development time.
Of course. Oh, makes sense. Makes sense. Thank you.
I agree here with simulation, but it's also reduce the cost and time to market, because we can create a robot in the design. We have design, put it into simulation, verify that it works. And we don't need, we can verify that it does the task that is expected, that it can reach each position that is expected. It can do such, to grab some things. And we are validating it and say, okay, we now can manufacture it, and it decrease cost of the solution because again, manufacturing is quite expensive and time consuming.
And simulation helps that to reduce it. Yeah. Perfect. Good. Guys, I think it's time in this episode to talk about the future. We've heard about implementations and how this impacts current business and how it evolved, including some AI. But now, I guess it's all about the future and how, how we see the future of human-robot collaboration evolving in the workplace. So, in a kind of office setup, maybe. Do we see that future?
Yes, if you are talking about the future, so humanoids robots are gaining more and more impact here. And why we are talking about humanoids? Because we have all the environments created for humans. And if we will have robots that are of the human shape, it will be easier for them to navigate in that environment. But there is a curve of robotics technology adoption that says that when the robot is far from being human-like, like a vacuum cleaner, right, or robotic arm, then it's okay because it's some piece of mechanism that works there. But when we are talking about humanoids, robots start to be more and more like humans. And there is some threshold where robots are more like they are like zombies, right? So they are like humans, but not like humans. Really. They act differently. The skin is different, etc. And this is the moment where the robots begin to frighten humans. And this is this gap that has to be crossed, because after that gap, you have humanoids totally like humans. So it will be impossible from the skin perspective, mimics perspective, hand manipulation and motion perspective, and also language distinguish human and robot. And I guess we are heading there. If you read the science fiction from previous century, so 1950s, 60s, it's all there. You just have to revisit and you will see where we are heading, because I guess lots of robotics were engineers and were inspired by that.
I can imagine, and this is the whole thing. It's actually quite ethical as well to think about this development of humanoid robots, because right now when I think robots, you think about those MIT or Tesla humanoid robots, which you can clearly see it's a robot, right? You can clearly see it, right? But then there's this kind of next evolution, and then there's already some out there which are human-like, like skin, texture, eyeball, and all of that. And I think that's the kind of thing that you're also talking about, which is this kind of threatening position of having human-like thing standing in front of you. That's a robot, right? And that's also that ethical question, whether this is the right direction, right? Because that might be scary, right? Walking around the office and then, people around you are not people, they're robots, right? So I absolutely get that. Yeah, I was more thinking about, coffee machine that, I can just say out loud, I need a cappuccino, right? And it will just kind of drive next to kind of my desk and bring me a coffee and set it on my desk, and like a concierge type thing in the office space. That would be something to maybe work on for our SoftServe offices.
Yeah, so and you can split this task into several chunks. First of all, the understanding of the environment, and you also mentioned this area that the coffee machine, let's say, has to understand where it is, where is the milk, what coffee, and where are you. So this coffee is brought to you, and from this perspective, we are there or almost there, because we talked about the foundational models. They are covering this, but there is one nuance that you have to have dexterity. So we have fingers, humans have fingers and skin, and we heavily underappreciate this fact, really, because skin is regenerating, and dexterity of our fingers is super significant. We can open wardrobes, shelves, we can grasp even tiny objects and successfully manipulate with them. And this is what robot is lacking. Like if you use your finger and you are touching something, you can tell what is the pressure is the object bending, is it soft, is it cold, etc. Robots are not there. In scientific world, there are sensors that can do this, but they are not widely introduced in the industry because of the skin. So you can put rubber over there and it will just be destroyed. So I guess this gap has to be closed in order to introduce robots in even more businesses. So in robotics, technology and business are deeply coupled. So as soon as technology makes a step ahead, business is there. So people are ready to introduce this. Of course, it is like innovators, early adopters, as usual. But still, we have a bunch of innovators who are ready to do this, but they're waiting for technology to be there.
No, of course, that makes sense. No, thank you. Now I will look at my hands in a completely different light. You know, I'll start appreciating my fingers more and skin. But you're absolutely right. You're correct. Yeah, those kind of sensors, like biological sensors, and that we speak of, right? Thank you, Lubomir. Yuri, anything to add on this topic on the future of this?
This artificial skin, it would be nice to have it, but I think near like 5-10 years, next 5-10 years, it will be impossible. But I may be wrong.
Okay.
But it's a really huge technology that can like enhance robotics world, because sensing over the body, I think it's really enhance the robotics. Because right now, yes, we can have with humanoids, we can operate with some objects, but it is very hard to get like feedback from the environment, that which, like with pressure, okay, right now there are some technologies that can do that, but if they efficient or it can be used everywhere, I think no, because like Lubomir said, from small objects till the very big objects, and to cover all these things like our skin, like you are touching something and you understand everything.
Yeah.
So far, yes, there are some prototypes, but they should be like they degrade with the time, and they must be replaced with the time.
Now, it just seems to me like there must be hundreds, thousands, or millions of sensors in this kind of robotic artificial skin, let's say, to actually perform the same job as your finger, which is this interpretation of the touch, the moisture, the texture, the pressure, and everything else, right? So not as simple as it seems, right?
Yeah.
Good.
If you are talking about something more closer, I guess the task that has to be solved for humanoid robot to be able to sit on the chair and then successfully stand up.
Are we not there yet? Really? I've seen robots that are making backflips.
Yes. Have you ever seen a video of the robot that sits on the chair?
No, actually, no. I thought it was a more mundane task.
So something complex is easier. Like humanoid can easily win you in a chess game.
Yeah.
But something like assembling a puzzle, let's say, with small pieces, we are not there at all.
So we learned how to run and sprint before we learned how to walk, pretty much. Okay, that made my day. Thank you for that. Any other breakthroughs? Go non-fiction. Anything we can expect in 10-15 years? I always ask this question, like about robots, is like, are we expecting actually at any time in the future to have personal assistants, humanoids, in our houses, or maybe like old people's houses, right? For example, right, supporting. Do we see that as a potential reality in the future?
Yeah, definitely. So humanoids will be helping elderly. And if you will think of the robot Pepper, so it was one of the robots that was doing that. So yeah, so that's something that will be
Amazing.
there for sure. Yeah. But again, it depends. So we've touched vacuum cleaner for a couple of topics here, and I had vacuum cleaner, and now I don't, because I have children, and my floor is covered with toys and clothes, and that's another problem for robotics to pick it up, and so that's
exactly my point. I actually put it away. It's somewhere in the attic. Like I don't use it simply because you're right. You know, lots of kind of objects are on its way, and that was my thought for this Roomba thing, to be able to actually determine what the thing is in front of it, move it, adjust its location, hover over it, and then put it back in place, for example, right? Something like that. Yes, I feel your pain. Yes, this dusting away.
But maybe we need a vacuum cleaner with RoboArm that can pick up all these objects and sort out where it should be located.
Oh, and clean after my kids.
Yes.
Oh.
Thank you, Yuri.
I would definitely buy one.
Same here.
Same.
Fantastic, guys. Lovely. Last question for today, actually. Maybe not even a curveball, but just for our audience who are interested in joining robotics space or maybe starting career in robotics space, how to do this? Like, do you have to go through like software development degrees, education? What kind of background, and how can we get into robotics?
I think it's,
you have to be like an engineer, I'm assuming, right?
It's a very, very hard question, because robotics, it is not only software engineering, not only electronics engineering, not only hardware engineering, but also cloud robotics, even software engineering. It is two different languages. We need to know simulators. We need to know algorithms. And it's huge, huge world of technology that, at least on the high level, on some areas we need to have deep knowledge. But it's for me, it's like person who wants to join robotics should want to learn first. It's person want to learn something new over the time, and even in the evening, okay, what technology was developed today? Like okay, what tomorrow to and try it. And try it on the, I don't know, simulators, work with, for example, with AI tools, because it's helping, but not usual. Because I already, like, I have an example with working with ChatGPT and writing robotics application. It wrote perfect application. It compiled and say it's working, but in reality, data was not exchanging.
Oh, okay.
And only changing in 2 lines of code make it work. And to make it but developer need to know what to change and where. And that means that, for example, currently, like even just these Gen AI tools are not mature enough to replace this even software development. That, okay, I'm asked like, please write me code to do that, and that, because I need that. It does this is the work, but not completely.
But you need to check it.
Yes, but to say it, like I tried such task a year ago or so, and result was even not not the compiled solution. But now it's better, so maybe next year it will be even better, and it will like work out of the box.
But it's a good place to start with development languages, right? Understanding software development, and then curiosity on top of that to learn and keep evolving.
Yeah, I want to support Yuri in the fact that a person should be passionate in robotics, because it is so rapidly evolving field that you have to always keep in touch with what's happening out there. And if you learn something today, then in half a year it will be outdated, and you have to live with this. But I also have good news that we don't believe that there is a full stack robotics developer. So the person that wants to enter the field does not have to learn everything deeply. So yes, some have general understanding of mechanics, electrics, AI, yes, but it should be more general. But you have to select one of the things that you are really passionate and interested in, and then you can learn this. It can be control theory, it can be mechatronics, it can be perception, it can be AI, whatever. But that's the thing that if you love this and you want to work with this, then this is something that you can have with the mild knowledge about the rest.
That is really
definitely there are area in robotics where the knowledge, your knowledge, could appear to be working.
See that, yeah, that's reassuring. Thank you very much. I mean, it seems like obviously this is a kind of mind boggler. Like you need to kind of have a brainiac, in order to understand it. But it's good news that you don't have to know everything. You can focus on a particular area of robotics, and then you can expand your knowledge onto other areas. Good. We encourage our listeners who are passionate about robotics to get in touch with us, and yes, we will definitely assist and help. Perfect, gentlemen. Lubomir, Yuri, thank you very much for this episode. Very insightful. I'm sure it was as much so for our listeners. So I appreciate you being here. Any last words?
Well, it was really pleasure to be here. Thanks for having us. And yeah, so
thank you.
Yeah, definitely. Thank you for having us, and it was great to talk with you.
Well, I enjoyed it a lot. So yeah, thank you very much. And to our listeners, stay curious until the next time. Thank you.
Yeah, bye.
Bye.